Hello, this is section 3.4 for Calc Survey, and today we'll be talking about the product and quotient rules. So again, adding more rules to your list that you need to make sure you can use to find the derivatives. So first is the product rule. So if you have two functions that are being multiplied together, the way I do it is I do first times the derivative of the second plus second times derivative of the first, and I wrote that over here. But notice it's not the order they do. So I do this one. I do first f times derivative of the second plus second times derivative of the first, which you can see because of the commutative property, it doesn't matter. It's just the way that I learned it, so it's stuck in my head. But this is the more traditional way of doing it, where you take the two functions, do the derivative of the first part where the second stays the same plus the first, and then times the derivative of the second part. But again, this is just how I'm always going to do it in class, just the way it's just because of the way I learned it. And then this is just using a different form of notation. Okay. So the product rule, if you have two functions that are being multiplied, then you can use the product rule. So you'll have the first function stays the same times the derivative of the second, 2x minus 3, plus the second function stays the same times the derivative of the first. And you're done. Yay. Now do the combined like terms, and that's your answer. So I did the same thing with this one. Now I always group the scalar with the first function just to be safe. You could keep the 3 out in front and distribute at the end, but you have that serious danger of forgetting to do that. So I always group the scalar with the first function. But this is our first function, e to the x is our second function. So first, 3x squared times the derivative of the second, e to the x is, remember, it's the easiest derivative, e to the x, plus second, e to the x times the derivative of the first, which this derivative, of course, is 6x. If you left this as your answer, I'd be perfectly happy with that. I rewrote it, and I even factored an e to the x out and an x and a 3. Any of these three answers would be perfectly acceptable. The reason we're starting to get you to factor things out is in the next chapter, we're going to set this equal to 0 to get some information out of the derivative. So that's why we're kind of pushing you a little bit to condense things down to one fraction, or to set your derivative, get it in this form, so when you go to set it equal to 0, you can use that 0 product property, and you know that 0, you set each part equal to 0. So that's kind of the idea. All right, so that's the product rule. Then the quotient rule is this. And you can see it's kind of hard. You're like, whoa, that got really complicated. Well, here's an easy way to remember it. It's low d high minus high d low all over low low. And what that means is low is your denominator, d high is the derivative of your numerator, minus high, which is your numerator, d low is the derivative of your denominator, all over low low, which is your denominator squared. Okay, so it's just an easy way to remember the quotient rule. And students will struggle to remember which comes first. And low d high minus high d low over low low takes care of that. You won't ever forget which part comes first. Okay. All right, so here are some examples of using the quotient rule. So here we go. Low, which is the denominator. D high, we'll use the chain rule we just learned. So pull the 2 down in front, inside stays the same. Don't forget to subtract 1 from your exponent, times the derivative of the inside. Minus high, which is the numerator. D low, and we'll use chain rule again. Here's your derivative of the denominator, all over low low. And then you have to simplify these. I will not accept, if you leave this where binomials can be reduced, that's wrong. That is, you have not finished the problem. So these you will need to clean up and reduce, because you cannot leave variables that can be canceled out, or binomials that can be canceled in this case. Okay. All right. And then here's another one where you can look, you're going to use the quotient rule. So low d high minus x squared high d low. And remember, the derivative of natural log of x is 1 over x all over low low. Then clean this up. And then if you left this answer, that's fine, because nothing can reduce, but you go ahead and factor an x out And this would be your better answer. But notice I put a box around this one because nothing can reduce. You have to make sure you cancel things that can cancel out. Variables, numbers I don't care about. It's the variables that I care about. Okay. So that's the product rule and the quotient rule, and you've got to practice these. Using these rules is not hard. It's going to be the simplifying that's going to be a challenge. It's going to require some algebra skills with, and you can already see here. So you'll definitely want to practice. Okay, now I threw some extra practice down here with your derivatives, and this is good because it encompasses a lot of what we've done so far with the product and quotient rules. So I'm going to look through here. When you're doing the derivatives, sometimes it might be beneficial to clean it up before you do the derivative. And this is an example. You have a fraction within a fraction. You don't want to have to do the quotient rule twice in one problem. So, and you don't want to have to deal with negative exponents. So it might be a good idea to clear the fraction, multiply by x over x, and then do this derivative, which will be so much nicer. And there won't be any negative exponents, or you won't have to do the quotient rule twice in one problem. Same thing over here. If you approach it now, you'd have to do the product rule and the quotient rule. And it's going to be a little bit easier on you if you go ahead and distribute the x. Now, derivative of 3x is just 3, and then you only have to do the quotient rule. But that's not the only way to do this problem. You could move that binomial up and make it 2 minus x to the negative 1, and you could do the product rule and chain rule. There's lots of ways to do these problems, and you kind of have to choose the path that you want to go down. And it's not, you might not always pick the easiest path, but it's kind of like those trig identities you did in pre-calc where you'll still get to the answer. It just might have taken you 3 or 4 more steps to get there. So, and that's something I've done so many of these derivatives, I can immediately see what the best path to go down is going to be, and you don't have that yet. You need to keep practicing and learning, and that's how you're going to learn, is by practice. So this one, you have to ask yourself, do I want to do the product rule and the quotient rule? If I leave it like it is, I'll have to do the product rule. So first, and when I go to do the derivative of the second, that's when I'll have to do the quotient rule, plus second times derivative of the first. Or should I multiply out the numerator and have just a polynomial over a polynomial, and then it's just one quotient rule? I kind of like that better, and it's going to be much easier to simplify that way. Okay, so sometimes it'll take some cleaning up before you go to do the derivative, and that's where you get in the danger of you spend time cleaning up your function and you think, oh, I did a lot of work and I got it to where I want it to be. And then students will think, oh, I did the derivative, and they'll put this answer on the blank when no, you haven't done any calculus at all. So sometimes you might need some algebra to get going, and then even more algebra to clean it up at the end. And you can see where all these potential little mistakes can be made. So you have to be careful. Now in this one, this would just be a pretty straightforward product rule. So first times derivative of the second plus second times derivative of the first, but make sure you're simplifying. That's why I put this in here. Make sure you don't leave this. If you leave this as your answer, that's where I'll have a problem. I won't want to see this. Make sure you cancel those x's. Okay. All right, then here down at the bottom is another one of those classic find the equation of the tangent line. And okay, so here's a perfect example of, do you want to tackle the derivative as it is? If you do, you're going to end up doing the quotient rule and product rule. Why not multiply out that denominator? Then you're just doing the quotient rule. Okay. But I also want to point out, we cleaned it up, then we did the quotient rule. If ever you're finding the derivative at a specific number, don't spend any time simplifying. You just immediately plug 0 in and get your answer. Don't waste time simplifying this, and you could make potential silly mistakes in doing so. So just once you get your derivative, plug your 0 in and get the number that we wanted, and then you're done. Okay. And then we do another one here. Now, when it's 3 terms, then it would work the same way. So let's say, I'm going to scroll back up here. Let's say it was FGH, then it would be F prime GH. FG prime H, and then the last one would be FG H prime. So it works the same with 3 terms. Or in this case, what we did is we multiplied the binomials out, making it just 2 terms like we were used to. So you could do first times derivative of the second plus second times derivative of the first. But it does work, the product rule does work with 3 terms, and you can do it that way as well. So, okay, product rule, quotient rule, not bad, but it's going to be the simplifying and the algebra behind it that's going to be the true challenge. So get used to those rules, make sure you can use them and know them, and then practice the simplifying. Okay, email me if you have any questions.